So that is how we are going to identify whether RE will appear at the input or output side. Now you see the simplified diagram is drawn considering RE. So I am going to split this diagram into input and output. You see here, input side, there is no RE. Emitter is grounded. Output side, output side, you have RCC and VCC, RC and VCC, and VCC I'm grounding. This emitter circuit is also grounded, and I take output from the emitter. Okay, so this is how you get the simplified diagram after checking whether RE will appear at the input side or output side. So 3 diagrams you should draw for analysis. First one is the basic amplifier diagram. Next one, considering where this feedback resistor will come, whether at the input or output side. And third one is the H parameter equivalent circuit. The 3 diagrams you should saw, and each diagram will follow from the previous one. So this diagram you should draw it correctly. From this you will be drawing how this RE is getting split, and from then you will be replacing this diagram with the H parameter equivalent model. You know, for a common emitter amplifier, what is the H parameter? So you will be replacing this transistor by H parameter equivalent model. See here, Vs, Rs, HIE. You know the input impedance of common emitter amplifier is HIE. And you know you will be having current source HFE into IB. Then you will be having this combination RC, RE across here. Okay, and across RE you measure the feedback voltage. Across RE you measure the output current also. Okay, so you take care of the polarity and other things accordingly. And RC is going to be your load. So collector resistance will act as load if there is no explicit RL in your circuit. If there is RL, then you have to see how RC and RL are available in the circuit, and you have to accordingly find what is the output resistance. So you see here, R0 is considering without RL and R0 dash is considering with RL. Okay, so similarly, if you consider R0, you'll be finding out R0F. R0F is without load and R0F dash is with load. You know, I measure VF and V0 both across the same resistance RE. So I can write beta value as 1. This beta value is Vf by V0. It is from the tabular column. So beta for voltage series feedback amplifier is given by Vf by V0. Here Vf and V0 are same because I'm measuring the same voltage across the resistance Re. So that is why this topology, it's going to be called as voltage series. The 4 topologies are there will be 4 different expressions for beta. So no expression for beta will be same for any 2 feedback configuration. So it will be going to be completely different. So for voltage series feedback, beta value is Vf by V0. And this is going to stabilize the voltage gain. Already you know the voltage gain is 1. It is going to maintain at 1 only. So on RS, I'm going to connect RS externally. And what current is entering your amplifier is going to be II. Here IA and IB are same because there is no more component between the source and the amplifier. So now we are going to find what is the voltage gain without feedback. Without feedback means the F suffix will not come. So AV, voltage series feedback amplifier, is an voltage gain amplifier, as you know. So it will have an voltage gain AV. So AV is equal to V0 by Vi. And V0, for finding V0, see the output side. Output side, find V0 across RE. What is the current flowing through RE? See, this current is flowing from top to bottom. So it is plus minus. So V0 is equal to current into voltage, current into resistance, HFE IB into RE. Okay. See, this is simple. Output side, you have only one loop. And you know, when the current source is there, that current is going to flow through both the resistance. So the current is HFE into IB and the resistance is RE. So V0 equal to HFE IB into RE divided by Vs. Now you have to see the input side and write what is Vs. So input side also you have only one voltage source. Vs is equal to IB into, these two resistance are in series. So Rs plus HIE. See here, Vs equal to IB into Rs plus HIE. I again say we are doing only KVL and KCL here, and we are drawing drawing the H parameter model. So it is feedback amplifier. It is going to be combination of your electrical engineering subject as well as your devices. So you should know KVL, KCL application properly for writing the equations at ease immediately. And you should know how to replace the H parameter equivalent circuit and finding out the gain other parameters. So you should be familiar in both. That's why I said you should, for making the subject easy for you, you should know the basics of BW and devices. Otherwise, it'll take a longer time for you to understand. So that is not a good thing, because you have studied the devices and electrical engineering. These two should be very familiar to you. See, where we are not doing anything, we are just applying KVL, KCL, Ohm's law only. We are not doing anything specific or special relating to feedback amplifiers. So voltage gain, IB and IB will get cancelled. So AV is equal to HFE RE by RS plus HIE. So this is going to be the voltage gain of the amplifier without feedback. Right? There is no suffix F here, right? So it represents the voltage gain of the amplifier